hello, hello, hello. Good morning or good afternoon, good evening, everybody, depending to where you are. Welcome to the second day of the Color Creative Week, where we are exploring all the new amazing stuff that we can do with color today. And this is probably the pinnacle of new stuff that we're going to be able to discover. We're going to be talking today about the Chat GPT and what we can do with it. Actually, I think I'm just going to kind of touch the surface of what's possible. It is still all in very, very early stages, but I hope that you guys are going to be the core of this community that is going to go and explore ChatGPT in much more meaningful way. There's amazing stuff that can be done with it, but actually you'll be surprised to what we're going to be able to do with it. So let's see who's online. Oh my God, very good. Max is here. Hello, and Gary and Roberto. Oh my God, Roberto, it's been a while. Good to see you, Luca. Good to see you, Luca. Excellent. Very good. And Peter, I can see Peter has been playing with ChatGPT himself, and Darren is there as well. Very good, Darren. Good to see you, man. Good to see you guys. Oh my God, there is Wilfred from Holland. Big, big, big international colorist crew. I love this. Sri Lanka. Oh my God, this is probably my first Sri Lanka. Thank you for joining. Thank you. Good to see you, Toronto. My God. Hey, Bobby, good to see you as well. Unbelievable, guys. Amazing. Italy and Germany. My God. Very good. Very good. So yeah, today we're going to talk about ChatGPT. Next month, I'm going to go more into stable diffusion stuff and everything we're going to be able to do with that. But without further ado, let me first actually just start a little bit like this. We're going to be like talking about what ChatGPT can do for us. But actually, just before I begin, can I just say congratulations to Andre Lavelle. Andre Lavelle has tuned in yesterday into our stream, and he got picked up by our algorithm, by our random viewer number, and was selected to win one Color Lab AI studio license. Woo! Congratulations, Andre, to you. And one of you guys today is going to go into draw to win second license. Every day we're gonna be giving away one studio license. So, keep tuning in, and glad to see you all here. Okay, so let's see what I'm going to show you today. So first of all, one and most obvious thing you're going to be able to do, or you can do with the ChatGPT, is to use it for learning. Really, like if you try to explain things, or if you try to learn about certain things or stuff, it's absolutely amazing. It really kind of writes very nice contextually about difficult subjects. I sometimes asking questions that just to check the knowledge, and I go like, oh my God, this is really good. I mean, you're going to see from a video, like it's just really, really interesting what I will be what you can learn. It is very, very, very useful for that. But sure, we want to do a little bit more just in learning. So I'm going to show you how to build custom DCTLs, and I mean your own custom DCTLs. So some of you might have had a desire, sometimes to make a technical transforms that are particularly yours, that you wanted to develop, that you wanted to have your own way of working, your own signature style, image processing pipelines. And you probably had a desire to, create a DCTL. Maybe you were even looking to hire one. There were even courses available, but it's not easy. I mean, it's definitely not for faint-hearted, and actually, with ChatGPT, I'm going to show you, you will be able to actually get them done. You'll see, I actually will be working together with you and show you how you troubleshoot it, and how you can go and start building your own DCTLs, believe it or not. It's crazy. It's crazy, actually. It's really, really crazy. It's really, really interesting. Okay, now you say like, okay, but I don't want to only do like, DCTLs. Is there anything more that I could do? And the answer is yes. there is a way how you can build your own 3D LUTs. Again, where you design your image processing pipeline and you put that whole image processing pipeline into a 3D LUT, and then you create that LUT and then you load it into your grading platform, and then you're going to be able to see this. So actually we can use ChatGPT to build 3D lookup tables, and that's also 1D lookup tables, which is also sometimes very useful. So I think these things are actually really useful, especially because these image processing pipelines can be made parametric, but I let me actually just kind of dive into it and just start showing you what is possible. I will start a little bit slower. I'm going to just kind of play a little bit with it. I was kind of using it first almost as I was interviewing somebody for a job. I was thinking, okay, could I get this person? And I kind of start like thinking this is that the ChatGPT has a personality, because every time you're asking the same question you get a slightly different answer, which is very interesting. I think Ilya, the guy who is behind it, he's definitely like onto something here, and I know that we are still far away from from kind of general intelligence, but I really feel that I'm connecting to ChatGPT. Anyway, let's go. I wanna guys share with you some of my discoveries. As I said, I'm not pretending that everything's working incredibly. You'll see how I'm working with ChatGPT to make things work, and hopefully this really inspires you. So let's start. So let's see what ChatGPT can do for us as colorists, right? And I'm actually going to really concentrate more on some difficult stuff, trying to maybe do some stuff with the help of GPT that I can't normally do using just color grading tools. Maybe we'll see, like maybe we want to develop some custom profiles, some lookup tables, DCTLS, anything's possible. So before we begin, let's just have a little bit fun. I'm using standard ChatGPT now. I do have a plus version, which just gives me like the accessibility. But you can do this with just a free version. Just register and start using it. Okay, so let's start with a simple stuff, just to see where we stand, right? So like for example, what I'm gonna say, do you know what is color science for motion picture film? Let's see, let's see how far we got that. Yes, I do. Color science for motion picture film is the study of how colors are captured, processed, reproduced in the control of film production. Color science plays a crucial role in the overall look and feel of film. Oh my God, it's actually really good. I want to copy and paste this. This is what I would like. Actually, if I was to teach it, what is color science, this would be fantastic. Yeah. There are several aspects, film, color grading, color correction, color management. Okay, great. Can you, I'm gonna be like this. Can you please tell me what is the most popular color grading system on system? Let's say just that. Okay, there are several popular color grading systems used in film and video industry, but one of the most widely used is DaVinci Resolve, developed by Blackmagic Design. Unbelievable. Okay, let's kind of test it now, like for example, like this. Hey, do you know what is Color Lab AI? Let's see. Yes, it started positive. Yes, Color Lab AI is a cloud-based color grading platform that uses artificial intelligence AI to automate and speed up the color grading process. It is developed by Color Intelligence. This is insane. I mean, we started in the cloud, right? So Color Lab was first developed to run in the cloud. So this was from few years ago, obviously, right? Because they stopped training the system. But it's unbelievable, you know, to look. Color Lab AI is designed to integrate seamlessly with popular editing and post-production software such as Premiere, Final Cut, and making you, oh my God. Oh my God. Crazy. Let me actually ask it. And do you know who is Dado Valentic? I mean, let's see. Yes, Dado Valentic is renowned colorist, color scientist, and founder of Colorists Society International. I'm not. He is widely recognized as a leading expert in color grading and has worked on numerous high-profile films. Oh my God. He's known for his innovative approach to color grading. Unbelievable. And he's also educator and has developed several training programs and workshops. It's true. Unbelievable. Oh my God. This is okay. I'm getting now. Now let's see if, can you do it? Okay. What is ASC CDL? Okay, let's see that. That's a kind of, let's get it into the color science part. Okay, so ACCDL stands for American Society of Cinematographer Color Decision List. It's standard format for exchanging color correction information. Unbelievable. It's really true. It's absolutely right. Do you know the formula for ASC CDL? I don't know if it's going to understand the formula, but let's see. Formula for ASC. Okay, let's see. Maybe it's going to do it. Yes, uh-huh. Yes! It knows the function. Unbelievable. Look, it knows. Let me ask a tricky question. Would you know how to convert this formula from slope, offset, and power to lift, gamma, and gain? Oh, gamma, I need to do this 1 second. Okay. I'm really excited. I really want to know if it's going to know how to do this. Let's see. Yes. Oh my God, I can convert. Here it is. It does. He understands that power is one, and oh my God, oh my God. He didn't quite give me the actual mathematical calculation, but actually, I trust that it understands the difference between it. It's unbelievable. Okay, it's unbelievable. Okay, let's get us this. Do you know Python library color, spelled British, right? Okay, let's see. Yes, the Python library color is a package that provides a wide range of tools and functions for working with color spaces. Beautiful. It knows it. Okay, now let me ask this. Can you give me a 3x3 matrix that converts from ACES linear, okay, to Alexa wide gamut linear? Okay, let's see. Boom. Okay, I was very loose, but it hopefully understood. Yes, you can. I can provide you with 3x3 matrix that converts ACES linear to Alexa wide gamut linear. But this matrix is used to transform color values from ACES, Academy color encoding system, to Alexa White Gamma linear used by ARRI cameras. To use this matrix to convert color between ACES linear to Alexa, simply multiply the matrix by ACES linear RGB values of color. For example, if your ACES linear values are blah, 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 the corresponding color. So, oh my God, so it's basically, just kind of giving you even an example. Okay, now, let's get practical. Okay, so this is like, theoretically I can see like, it's giving me, some, values, but, let's start testing and seeing if these values actually, really work. Okay, let's say, do you know what is Da Vinci Resolve DCTL? How about that? Okay, yes. Of course, I know everything about DCTL. DCTL scripts are created using a syntax that's similar to C. Unbelievable, knows that as well. Okay, so could you make me a DCTL that converts from ACES linear to Alexa White gamut linear. Okay, great. Let's see. Boom. Could you do it? Certainly. Here it is. It defines it. Okay. Float. It calculates. And this DCTL script defines 3x3 matrix ACES to Alexa White gamut that combines color values from ACES linear to Alexa White gamut linear, and then applies this matrix to each. To use this DCTL script, just put it in. Okay, now let me just check. I think it's looking correct here, right? It defines it, and then it uses the function. And then it multiplies and all of it. But there is an error here because it's defining device as a parameter. Okay, wait. I understand what it's doing. Okay, can you rewrite the above script so that the device tells Da Vinci to use GPU. Okay, let's see. Okay, device for blah, 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 blah. Okay. Okay. In this version of the script, we include the device directive at the beginning of the script. Yes, that's what we want. We want that. So the rest of the script, okay, is the math. Okay, now it's good. So we have to define, pretty good. Okay, now let's go into our, let's say, file, new window, and then I'm gonna go and just put here, don't need this now anymore. Okay, great. Let's just go. I'm going to put this as DCTL, and I'm going to go and save as. And I'm going to save it as ACES to Alexa .dctl. Okay. And then I'm going to say save, because now it's got saved. Let's see. I'm curious now to see if this is going to work. So ACES refresh. So we have ACES to Alexa. Okay, great. So now let me just try again this one. So ACES to Alexa. Is this going to work? Boom. And now it works. Yes. We got it. We got it. We got it. It does need a little help, right? But like I'm pretty certain that I can, write a prompt that is just going to give all these instructions first, so I don't have to like tweak it like this. But yeah, as you can see, basically I got the matrix 3x3 matrix to work, and it's my custom matrix. Now think about, all the different conversions and matrices we could do and stuff, sometimes when we need just a very particular technical transform. Okay, now let's go. Like, DCTLs are fine, but how about we go and create some 3D LUTs, right? Now, the way how you create a 3D LUT is really, by using Python. Really, like, this is the best thing. You write a formula, you write, something that then spits out the Python code. You kind of, don't really want, ChatGPT to do the math itself. So what we're going to do is we're going to try, to do that. So let's say first, okay, so I'm going to say this. Can you write a Python code that. Now let's try to be a little bit more specific. Okay. Okay, Python code that outputs a 3D LUT in size 33 by 33 by 33 in .cube format. Okay, so that's a kind of the beginning. So let's say we want that. As an input, we are going to have R, G, and B in float values with bounds of 0 and 0 and 1. Okay, so we know that the signal that comes in, has to be 0 and 1. That's good. Then we are going to apply an S contrast curve, and the output result as 3D LUT with output bounds for RGB. Okay, let's go RG and B with output for RGB, with output bounds for RGB to be 0 to 1. Okay, so kind of I'm like just giving it a little bit more, instruction to what to do. But effectively, we're trying to say, hey, give us an 3D LUT that's going to have an S curve and output it in a particular format. Okay, let's see what's going to happen. So sure, here is it. So it's going to need an NumPy, of course. So LUT size is 33. LUT input is this. LUT output. Okay. LUT size. Okay. Print. In this code, we first define the size of the LUT. Then we create an array, the values ranging from 0 to 1, and apply S contrast curve to array to obtain a LUT output. We create a 3D LUT. Finally, we save 3D LUT in .cube format, which entry of the, with each entry in a triple RGB. Size and the resulting 3D LUT is saved and named as a output LUT.cube. Note that this assumes that S contrast curve is applied to each color channel independently and that resulting output values range from 0 to 1. If the S contrast curve is applied differently, the output values. Okay, great. Okay, this is great. My only other thing that I think, has not done, okay, I'm going to say this is great, but could you please add to the output LUT, to the output LUT in the first line. Let me just check, this is called, we have a particular line we need to add, to the LUTs, which I think it's called LUT underscore size, and then 33. That's, I believe, normally, like, what, the LUTs need to have. Let me just quickly check this for you. 1 second, because I have here, like, I just gonna open a lot quickly and just see what it needs to have on the first line. So I'm gonna open it with my text editor. So, okay, great. Here we go. So it should say lat underscore 3D underscore size 33. Okay, great. So then we're going to do that. So we're going to say, okay, lat underscore 3D underscore size 33. So that's a you know, just an additional thing. So sure, let's see. I'm just going to go and do this. Perfect. Okay, so now it's basically, you know, writing a script for that. Okay, cool. So let's go and test it. Yeah, perfect. Okay, so I'm going to go now and copy this code. Then I'll go back into my text editor. File, a new file. I'm going to go this. And then what I'm going to do is I'm going to save it as a Python code, and I have an environment. You know, it's actually really, you know, good practice that when you are, you know, doing any sort of development like that, that you have an environment. So we're gonna call this s-curve dash 33 dot py. Okay, so this is my basically Python script. Now let's go and open our terminal. Let's see, now we need to just do a change, you know, to our environment. So let's do that. So I'm just going to go and say cd, and here is my environment. Okay, perfect, excellent. So now I can just go and quickly change that. And then I'm just going to go and say Python 3, you know, which is how you initiate, you know, Python on a Mac. On Windows is also very similar. I mean, you know, this is something that I could actually make a course just about, you know, doing this stuff, and then it's gonna go and output a lot, right? Dot cube. So you see, there we go. This is the resulting out. Okay, so now it says, hey, let's try to open it, and it really couldn't necessarily open. Let's see, so there is a little error there. So I'm gonna go and open with Atom. Let's see what it did. So probably has some sort of, oh, the one App Store, sorry guys. Let's go open with other Atom. There we go. Let's see, there is like a probably, you know, something going on. Oh, this is not good. So what I'm going to tell it now is I'm going to say, can you rewrite above code to use input and output values to be float 0 to 1. Okay, cool. So now basically what I'm telling it is just I'm saying, like, you know, we are actually, you know, gonna be using float values. Okay, fantastic. Okay, great. All right. So note that in this code we write RGB values in float format with 6 decimal points. Fantastic. Okie dokie. Cool. All right, so let's see now. I'm gonna copy this. Let's go back into my code. I think this was the one we were using earlier, so we can just rewrite it. Okay, great. And then I'm just gonna go and save file, save as s-curve pi. You know, that's correct. So we want to replace it, please. Fantastic. Now let's go into terminal. Let's try again. So again, I'm gonna go and say again around this one. Okay. Okay, so now it says, okay, it did output the cube file, and now I'm gonna go and try to open it. Let's see what's gonna happen. And now it works. Okay, great. So what I'm gonna do now is I'm gonna go into my, oh, actually, I don't have to go anywhere. I'm here. I have a folder called XTools where I'm doing this experimental stuff. And then instead of, calling this output lat cube, I'm going to call it S-curve lat. S-curve lat. Okay, and now I'm going to go and copy that. And if I go into DaVinci, and I'm going to go into DaVinci and in my XTools do a refresh. Fantastic. Let's see. Is it going to go and give me S-curve lat? It's there. So if I was now to try to put this S-curve on the output, it does it. It's unbelievable. It's unbelievable. It's unbelievable. But now let's when we are already kind of on a roll, let's try one more thing, just for fun. Okay. Okay, I'm gonna say using the same input and output profiles and input and output bounds. Could you write a new Python script that would apply a film stock emulation? Okay, why not? Let's see what's gonna do. Oh my God, certainly. I mean, I'm so used to this. Certainly, I can do this, okay, so it's now what it's doing, it's kind of using something because input output is ACCG and output is Rec 709. Contrast, okay. Oh my God, let's see what it did. Convert the output image to output profile and bounds. Output PNG. All right, so it's outputting save. Oh, it's also saving an image as well. This is great. But instead of processing an image, just create a 3D lat as an output. Just create is here, like create a 3x3 lat in size 33 by 33 by 33 as an output. Okay, right, so that's all we want. Okay, so let's see. So now we got the new code, and it says in this version of the code we remove the parts that load the process of an input image. Yeah, that's exactly what we want. We didn't want to have an input image. Okay, so now we're going to copy that. Let's save this as basically a code. Okay, so this is my new film print. We're going to save that. Let's run this and see how that's going to work. Film print. Okay, cool. Now we go. Excellent. So this is my film print lat. Let's go into DaVinci and see how that's going to work. Okay, so these are my tools, refresh. And here I'm just going to, at the end, going to go and put my film print lat. Let's see. It's insane. It is insane. Well, what can I say? What can I say? I mean, this is really unbelievable. It's actually really unbelievable, what we are able to do and create now, writing, this scripts used to take a very, very long time. I mean, it's still not idiot proof. Like, you still have to know what you're doing somehow. You need to understand a little bit how that code should look like, so you can't, but maybe like if we develop prompts a little bit better and have some sort of better way we are prompting ChatGPT, I think we should be able to get quicker to better result. But I really would like to open, this, discussion to the community, and I would love to invite you to come to the Discord server. We'll have a channel just for ChatGPT where we can meet and discuss and share some of the prompts and understand how best to get to the best results in most quickest way. In certainly I actually can't believe that I will be working without it. Because I don't know why would I do all this stuff manually like the way I used to do it, because this is 10 times faster at least. So yeah, so I hope you liked this little insight into what ChatGPT can do for colorists and color scientists, and I'm looking forward to hearing your feedback. Thank you. I can see the chat's going crazy. I'm sorry, guys. I'm sorry. I muted myself earlier. I forgot to unmute. Okay, I'm back. I'm back. I'm back. I'm back. Thank you. Thank you. Okay, so where was I? What was I saying? Let me try this again. Okay, so I wanted to tell you this. So you are going to be able to rewatch this video, of course. And also all of these scripts I created in this video, and the DCTLS and the prompts I was using, I will share on our Discord. We'll actually open a dedicated ChatGPT channel where we can just, contribute and share stuff and put some prompts and, do stuff. If you are interested, I'll make more YouTube videos about this. I mean, this is of course, this is just, the beginning, right? And we can start exploring. You can see that it's not bulletproof. So the art of engineering, they call it prompt engineering, right, is going to play a significant role in the future. You cannot assume that that these technologies are going to be so good that they will be able to read your mind. You still have to be able to kind of very narrowly push them in a direction to what you need to do. So you see, I had to have several iterations before I was able to get my DCTL to work. Okay, but as we work more with it, we will understand and find the ways how to prep our prompt in order to avoid some of those pitfalls, right? So it's going to be probably just kind of a one-liner or one block, that we can do. So the better we get, the more experience we get, the more we discover what works better or not. So this is really, I think, where we as a community can do a lot together. Where we can understand, much more when we start, sharing these ideas, which is why I, just go to collab.ai/Discord. It's Art of Color Discord, and just look for, ChatGPT channel there. And straight after this stream, I'm going to go and post, these scripts and everything, so you can actually start using them yourself. So that's it. I hope you like this, guys. I really hope you like this. I certainly think, that the future is going to be amazing, to what we're going to be able to build, and that many of you who have, always wanted to make, some sort of DCTLs are going to finally be able to do this, make some beautiful, parametric DCTLs as well, or, build some amazing LUTs and stuff like this. I really think it's going to be absolutely, absolutely amazing. I want to remind you that tomorrow we're going to be showing you how to bring basically, let me just remove my logo on the top, and how to bring advanced color management for Adobe Premiere. If you are working with Adobe, you gotta watch this, because there was one thing that Adobe is missing is this kind of high-end image processing engine. And tomorrow I'm gonna go and dive into it, and especially this is super useful. What I will do is I will basically color grade everything in Premiere, and then I'm gonna go and move it for Dolby Vision mastering in DaVinci to deliver to Netflix. But that workflow is so seamless. It's actually something I did for one of our clients. They have a reality TV show that goes out on Netflix, and they cut everything in Premiere, and they just really need to, very quickly go out of Premiere to Dolby Vision, and they had a huge, delays by having to export, relink, color grade, regrade, rematch, so it was just a nightmare workflow. So, with this, advanced color management that we're bringing to Premiere, they were able to literally just, finish it in 2 hours. It's a huge time saver, and it's just amazing, to know that, you can actually now do some very advanced stuff, when it comes to color management inside Premiere, like you can do in a base light, or what you can do in DaVinci. So it's going to be very, very, very good. I am going to also, somebody asked for Stable Diffusion. Yes, I am using it. I'm playing with it. I absolutely love it. Next month, I'm going to make, more videos about Stable Diffusion and stuff that we're going to do. It's not video ready, but there are some great tricks that you can do with it. So as I said, just guys, watch this space. Please, as I said, hope to see you all at the Art of Color Discord. And thank you all for tuning in, and thank you for being such an amazing crowd. And I'm really, really looking forward to seeing you all tomorrow. Same time, same place, maybe less AI. Actually, some AI is still included, right? But, really, really interesting stuff that we're going to learn tomorrow. So thank you all. Enjoy your day. Thank you very much. And